Okay, so the next problems are going to involve power. So a 75 volt generator, so V equals 75 volts. Again, read through the problem, pull out all the numbers. Supplies 3.3 kilowatts of power. So power is P is equal to 3.3 kilowatts. And remember to convert that into SI units. A kilowatt is 1,000 watts, so that's 3,300 watts. How much current does the generator produce? So I want to find I equals question mark. All right, so we go to our equations involving power, and our equations involving power. We have a chain of three equations here. So we've got P equals IV equals I squared R equals V squared over R. So what does that mean when I do a chain of equations like that? It means it's the same thing. So power is equal to IV, power is equal to I squared R, power is equal to V squared over R. And so we've got these three equivalent equations, and what you do is you look and you see which equation works for what you're given in the problem. So I'm given P and V, and I want to find I. So if I look at the three equations, here I've got P, I've got V, and I want to find I, so I could use the first one. If I look at the other two, I've got P, I don't have R, so I can't use that one. I've got P and V, but it'll just, if I rearrange this one, it'll give me R and not I, so I can't use that one. So I'm going to use the first equation. So P equals IV, I got to rearrange that to give me I, so I is equal to P over V, just divide the V on both sides. So now it's just plug and chuck. 3,300 watts over 75 volts, and I get a current of 44. Unit for current is amps. Okay, so pretty much straightforward. In any given problem, they'll tell you two of the things, and you just have to pick which equation is correct to find the third thing. All right, let's do one that involves cost. Okay, so I've got the current in a 120 volt reading lamp is 2.3 amps. So let's interpret that. So I've got V is 120. The current is 2.3. And they tell me the cost of electrical energy is 7.5 cents per kilowatt hour. So that's $0.075 per kilowatt hour. And the question is, how much does it cost? So the cost, I don't know, it's a dollar sign, right? How much does it cost to operate the light for a time of 1 hour? Okay, so when you're billed for electricity, you're not billed for power, you're billed for the total work that it does. All right, so the work that it does is equal to the power times the time. Okay, so let's just figure that out. So the work, or the energy, is power times time. If you remember from physics 1, we had the definition that power is equal to work over time, or energy over time. Right, so you're being billed for the energy that the power company is sending you. All right, so power times time. So I've given the time is 1 hour. I've got V and I can figure out the power. All right, so what's the power? The power, I've got those three equations. Power equals IV, power equals I squared R, power equals V squared over R. Which equation do I use? Okay, we'll again go through. I have I and V. Okay, I don't have R, so I can't use either the second or the third equation. I'm going to use that first equation again. So my power is equal to the current, 2.3 amps, times the voltage, 120 volts. So my power is 276 watts. And we're getting billed in kilowatts. So let me put that into kilowatts. So divide by 1,000, 0.276 kilowatts. All right, so now I've got my power and I got my time, so I can go back and I can put those into that energy equation. All right, so my energy is equal to the power times the time. I want to get that in kilowatt hours. So I've got 0.276 kilowatts times 1 hour. That's convenient. So I just get 0.276 kilowatt hours. The symbol for watts, that's a capital W. All right, so now I know how many kilowatt hours I use. So if I want to find the cost, I'm just going to multiply the number of kilowatt hours that I used times how much it costs, right? It's like if you go to the store and you buy a t-shirt, okay, a t-shirt costs $5 each, and you buy 10 t-shirts, what you do is you multiply the cost per t-shirt times the number of t-shirts. So the cost per kilowatt hour times the number of kilowatt hours, that's going to give me what the total cost is going to be. So the cost per kilowatt hour is 7.5 cents. $0.075 times the number of kilowatt hours, which is 0.276. So how much is it going to cost? Not very much. So it's $0.021, which is, if I convert that into something that sort of makes sense to our brain, is 100 cents in a dollar. So it costs only 2.1 cents. So not a lot of money to keep your lamp on for an hour.